This meeting is being recorded.
Yes. So welcome again and very good morning to all. And it gives me a great pleasure to extend a warm welcome to everyone present here on the fourth day of the faculty development program on smart building design towards net zero. We are truly honored to have Dr. Sanmarga Mitra with us to deliver an insightful session on the topic of thermal comfort on the traditional indigenous architecture over contemporary residential architecture of urban India, or case study of Kolkata. Sir, your expertise and research in this field are of immense value, especially as we explore the sustainable and climate responsive solution that bridge our architectural heritage with the modern urban needs. And your session will undoubtedly inspire our participants to critically evaluate current practices and reimagine the residential designs in the context of the energy efficiency and human comforts. So once again, we warmly welcome you. And now I call Subham Meena sir to briefly introduce the session expert to the participants. Subham Meena sir.
Thank you so much, Ravi sir, and good morning, everyone. It is my pleasure to introduce our today's speaker, expert Dr. Sanmarga Mitra, who brings with him a rich blend of academic insight and practical research in the field of architecture, planning, and building sciences. Dr. Mitra is currently serving as assistant professor in the Department of Architecture at the School of Planning and Architecture, Bhopal. He holds a bachelor's degree in architecture from Jadavpur University, Kolkata, and master's degree in planning from IIT Kharagpur. He completed his Ph.D. from NIT Patna, with his doctoral work focused on thermal behavior of indigenous and traditional buildings. Our topic of critical relevance in today's discussion on sustainable and climate responsive design. His academic journey includes a decade of teaching at Birla Institute of Technology, Meshra, and its international center in Ras Al Khaimah, UAE, where he contributes significantly to architectural education and research. His interest ranges from thermal comfort and structural behavior of buildings to the history of architecture, with a particular emphasis on traditional knowledge system and their relevance in modern context. In today's session, Dr. Mitra will present on the topic thermal comfort of traditional indigenous architecture and contemporary residential architecture of urban India, a case of Kolkata. This presentation offers a compiling comparison between traditional and modern housing typologies, revealing how indigenous design practices can outperform contemporary solutions in delivering occupant comfort, especially in the context of India's composite climate zones. Please join me in extending a warm welcome to Dr. Sanmarga Mitra.
Thank you.
Thank you, Subham sir,
Am I?
for briefly introducing the experts. Sanmarga Mitra sir. Now I call to the Sanmarga Mitra sir to start his session. Sir, over to you, sir.
Thank you. Am I audible? Hello.
Yes, sir, you are audible.
Yes. Yes. Okay. Okay. Thank you. Thank you, professors, for giving such a wonderful introduction for me. I'm very sorry. Extend my apology to all present here for being inadvertently delayed in joining, which actually my installed Webex app forced me to do. It was updating the moment I put it. So without further delay, let me just start my presentation. Yes, I hope this is visible to all of you.
Yes, sir.
So today's topic has already been introduced by Professor Meena, Professor Shubham Meena. This is actually part of my research. So I'll be presenting that. The topic deals around three basic highlights. One is thermal comfort of residential buildings in India, specifically Kolkata in this case as a case study. The second part is traditional indigenous architecture, and third part is contemporary residences, which we see all around in Kolkata and in many other cities of India. Now, introduce that particular research, why the research was initiated. I would rather highlight the last point in this list or in this particular chart. This particular chart proceeds from top to bottom in terms of spatial scale. So we start with global warming, then region, local, and then ultimately urban centers. So this urban heat island or urban heating is the main thrust area which necessitated the research, and hence the research was further taken into. If we refer to this particular IPCC map on this city level urban heating, we find all over the world there are cities which have heated up in last 30-40 years or more. So this particular map shows a time span of around 68 years, starting from 1950 to 2018, and shows how different prominent or famous cities all over the world, they have taken up the effect of global warming into a city level state. And where we see that Kolkata in the map shows that it has taken up the maximum amount of warming in the heart of the city, or the urban warming as we call it. Now, our research was actually aimed at finding out the root cause for such warming, and so that necessary steps can be propagated. So in order to do that, the moment the problem was identified, or the problem city or the case study was identified to be Kolkata, the next level was to look into the factors which actually contribute to the heating. And it has been found from different studies that the root cause for warming of any city is its geometry. And then that's on a macro scale. And the more and more we go into micro level, into the building level scale, we find that the heat retaining properties or the thermal performance of the buildings and the road are one of the major contributors to the problem of urban heating. The materials that make up these cities, as the slide reads, are very good at reabsorbing and retaining the heat during daytime and then re-emitting them during nighttime, contributing to overall warming, day-by-day warming of the city itself. And then comes the urban heat island effect, which is further amplified if the city lacks vegetation and water bodies. And we all know that Indian cities are, in most cases, not all, but in the major cases, are losing on these two attributes. Urban water bodies, even in our school or college days, 2-3 decades back, in the city of Kolkata or in any urban city around in the eastern region, we used to find so many ponds, neighborhood level ponds, or I'd say uh, regional level ponds, which were there, water bodies which were there, which are no longer existing. Anyway. Incessant cutting of trees, another problem. We have to develop, so we have to sacrifice something. Trees, easiest prey. So the three levels of architecture and urban heating, the three facets, urban geometry contributing to it, with the form of building, proximity of built masses. These are the two things which actually come up from the urban texture or urban geometry of any city that we find. The second level, human activities, where most of the perception of comfort comes up, in the same environment, within the same building, different people behave or react differently to the problem of heating, depending on their perception of comfort, which is again in turn affected by many physiological attributes as well as activity patterns of the particular person. And then the artificial intervention comes up to solve that particular problem. Air conditioners, air coolers, different types of mechanical uh, control systems, they come up to compensate the heating. And then lastly, the material level, which is the minuscule level in designing and construction of any building, the thermal insulation of that, local availability of that, all those. These are basically some of the thrust concerns that we have. And if we now get into the mitigation of UHI, what are required in order to mitigate urban heat island in any city, we can divide it into two different scales. One is, again, as I said, urban scale, which is beyond the purview of this particular research and this presentation, and the one which comes within the scope of this particular presentation is building level, which has, say, uh, approaches like shading and solar control, green roof, green wall, and courtyard centric planning. So these are the main thrust areas that we have. So with this small background, the research that was taken up, has been taken up and concluded, has two major research objectives. The first objective is to find out whether old indigenous residential buildings of Kolkata actually show better thermal performance than the new residential buildings of the city. Is it the new buildings? Is it the new residents which is actually contributing to this urban heating? Say what the IPCC map has shown from 1950 to 2018, the increase of 2.6 degree centigrade of an average increase of that particular temperature has happened for this particular city. Now, what was responsible for that? Is it so that the residences, which constitute more than 50% of the total land use or the total built up mass of the city, they are not so competent? I'm uh, putting these three words or the entire phrase within quote bar, that whether these new residences are not so competent in order to cope up with thermal comfort or thermal performance, which is required for the basic thermal need or I'd say basic thermal condition of a human being or of an occupant. And in order to cope up with that uncomfortable thermal comfort, people are relying more and more of mechanical services, which is again in a vicious cycle contributing to the environmental heat sink of uh, the city. It is taking up, absorbing the heat from the inside of the building, throwing it out into the outer environment, which is again heating up and then again heating the building. And the whole cycle goes on and on and on, contributing to a very steady, slow but steady rise in the overall temperature of the city. So that's what we wanted to prove first, whether the old buildings are more competent, whether the new buildings are not so much competent. Well, if so, then the second part of the study was to ascertain the degree of association between the indoor thermal condition of old as well as new building with the physical factors which are affecting their thermal condition. So each particular design attribute or construction attribute or building attribute, as we can say, has the best correlation with the thermal comfort condition. And so that we can identify them and, if possible, reincorporate them in these new building, which will actually help the new design cope up. Now, the whole thing for conducting this particular research, there were three major steps. So I'm coming to this particular slide a little bit early so that we can understand the sequence of the entire presentation in a easier manner. There were three sets of data which were collected in the whole process of the research. First of all, identifying those buildings. Then second, preparing measure drawings of the buildings so that the building geometry becomes very clear to the researchers. And the third is collection of thermal comfort data within the building. It was a very simple, I would say, methodology adopted. Coming to the next thing, what were the different types or component process which were involved in the whole research? The very first component process that were involved in this particular research was, first of all, identification of the factors which were responsible, their parameters and their indicators, all these. Second, getting the thermal comfort perception or the thermal performance, which we will find later on. And the third is the comparison of the old versus the new building. Now, in this, there were two components which were majorly or predominantly quantitative process, which were the factors responsible, obviously, the listing of factors and parameters and indicators, and comparison, which was again a quantitative comparison undertaken as part of the research. At the same point of time, the thermal comfort perception was a qualitative process. Now, here I would, although we have our main data analysis by the end of the presentation, but here I would like to highlight one certain issue is that when we took up the research, the common thermal comfort researches which are undertaken all around India and the world takes up a qualitative approach where the researcher conducts a feedback survey from the occupants, and the perception, the thermal perception of the occupant is taken into consideration in the research itself. Although the initial stage of this particular research also aimed at the same thing, but then while conducting the measure drawing and the study of the old buildings, we found out that there were a large inventory of old buildings, old residential buildings in Kolkata, which are in good shape, but they are currently unoccupied. The reason, the primary reason, there are various reasons that were identified, but the primary reason was some sort of a legal problem among the current owners. It's not very clear that who owns the property, hence nobody owns it, and there is nobody. There are legal procedures going on in the court. So the building remains unoccupied in this case. In many cases, the actual owner of the building is untraceable. The buildings are quite old. The oldest building that I have studied dates back to the time of the Battle of Plassey, around that. So these were the problems, and we found out that a majority of this old building that I have studied are unoccupied, as I said. And because of that, the feedback, thermal comfort feedback from the user cannot be taken because there is no user as such. So we actually search for indicators which doesn't depend on user perception feedback as such, and rather goes into a more non-human, or I would say machine-based feedback process. And we ultimately found such indicators and used them in the particular research. So the whole research doesn't consider thermal comfort perception survey or feedback from user, or rather the user feedback. So that part has been taken out from the research. So the whole research has become purely quantitative research, not much of qualitative approach in it right now. And hence, from this point onwards, except for a few places. In most cases, we have not used the word thermal comfort, but we have used the word thermal performance of the building, which we have defined for the purpose of this research to be a non-human based, uh, let's say, uh, a non-human based indicator. Okay. Coming to the three major components, the methodologies that have been used previous to this research in other researches, uh, factorial analysis of parameters and indicators, obviously, measurement of indoor climatic condition, measurement of outdoor climatic condition, identification of factors influencing climatic condition, correlating the factors with the climatic condition. Then the thermal comfort perception, as I've already discussed, was there in the study, but was actually taken out. And then comparison of old versus new building on thermal performances. There can be so many methods. Simple visual, tabular or graphical comparison can be done, but they are obviously non-reliable. So a more analytical comparison through testing hypothesis or other analytical methodologies that have been used. Coming to the particular case study or the city, Kolkata and its architecture. Here we will briefly discuss about its three aspects. Introduction to the city, the major urban texture that is observed, the urban texture and urban fabric of the city, and typologies of residential buildings of Kolkata. This brief discussion is required before we go to the specific case studies or case buildings that we have studied as part of the whole research. Now, the city, which was erstwhile called Calcutta, is a city where major urbanization and building activities started with the inception of British occupancy of India. Although at present there is no unanimous uh, decision on the date of establishment of the city or the year of establishment of the city or foundation of the city, because there were already settlements in the area where the city started growing. So historians do not endorse with that particular specific year, but here we are actually concerning that the major urbanization and the building activity started with the British occupancy. And the pre-independence architecture of Kolkata could be grossly divided into two parts. First one are the buildings belonging to the European quarter of the city, obviously the Britishers and some other Europeans as well. There were Greeks, there were this Dutch and other occupants who have Armenians who have come up and settled in the city. And then there were buildings belonging to the non-European or Indian quarter of the city, which the Britishers used to call the native quarter of the city. So I've kept that particular word at least in this slide. So the city started growing somewhere around 1690s. These are the four maps which I could get from the paper written by Mr. Nair in 1990 on a book. It was a compendium on the history of Calcutta, edited by Professor Banerjee. So in the year 1690, we can see there are three small hamlets which are there. Tutanuti, Kalikata, or which later on will become Calcutta and now Kolkata, and Govindpur. So these three were the three hamlets on the bank of the river Hooghly. And then by within, say, around 60 years of time, we find that the whole city has taken its seat. By 1785, we have got a clear structure of the city. There was a, if you notice this third map, which is dated 1785, and if you also see the map which I have rotated to accommodate it in the slide itself, map of old Kolkata 1784 to 1785, you will notice that there is a Maratha ditch which is encircling the entire city. protecting the city from the raids of the Maratha riders, cavalry called Burgis. And this was a canal which was excavated by the Britishers, now has been converted into a road. Even after that, when the Marathas were no longer a threat, they converted this whole canal into sort of the first radial road around the city. Now, this is one of the main central artery right now in the city itself, called the Circular Road. The name is still there, which refers to the circular pattern or the radial pattern encircling the city itself. So that circular road or the Maratha ditch is visible over there. Now that actually created the boundary of the old city. And because of the Maratha ditch, the city, the densification of the city happened within the physical premise where we have on the western side of the city, the river Hooghly flowing, and on the eastern side, Maratha ditch or the Maratha canal, which were there. So that this whole thing delineated the outer limit of the city, with the southwest of that particular place being, I just try to switch on the highlighter. Yes. So I hope this pointer is visible to all of you. So on this particular side, we find that on the southwest corner of the city, a new fort was established by the Britishers, the Fort William, which is there. And then by 1921, why this particular date of 1921 is important is because by 1911, the capital of British India got shifted to Delhi. So this is the post uh, that shifting delineation of the city. By the time of uh, independence, and even now, the central part of the city retains this geometry till date. So that's the updated version of the city. The city has grown multifold beyond this particular place, and this is now considered to be the heart of Kolkata, or the main Kolkata city itself. Uh, and this particular graph shows how the urbanization kept on growing and on and on and on, where we can see from this map right from the inception, that is from 1656 to somewhere around 2000, the year 2000, how the whole city has grown. The new city of, or the satellite city of the Salt Lake have come up, Salt Lake and Rajarhat, all these have come up in the city. And the predominant growth thrust of the city is now towards southeast as well as southwest of the city. So that's the direction in which the city is growing right now. Coming to the urban fabrics of Kolkata. Now, this part of the city, we are not going into the larger extent of Kolkata, which is also delineated for administrative purpose as the Kolkata Metropolitan Area, or KMA, which is being governed by the Kolkata Metropolitan Development Authority, or KMDA. So we are not going into that larger extent of the city. We are more interested in that nutshell of the city, which we are highlighting as the old Kolkata. And then the new Kolkata, the new residences that we were talking about, are again new buildings which have been designed within this old Kolkata area itself. Okay, so that's primarily our area of study, or the zone, the region of our study in this whole process. Coming to the urban fabrics, the very first urban fabric that we should look into are the European quarters, because it was the Europeans ultimately who started the urbanization uh, in this particular city. In this uh, part, I've tried to take up very small areas. It's figure ground map and the satellite image to show you how the different buildings of this different quarters or different fabrics of Kolkata started growing up. This one highlights the Governor House and other areas within the Dalhousie area. This one is the BB Dibag There is a huge pond over there. So that's this area. So that's the part of the European, the purely European part of the city.
This meeting
which
is
they have
being
designed and
recorded.
constructed. The next one is indigenous quarter. At the same point of time when this European quarter was being built up by European architects themselves, being constructed by them or being supervised by them and constructed by the local masons. At the same point of time, the wealthy Indians, the wealthy natives are constructing these parts of the city, the Chitpur and then Pathuria Ghata, Jorasako. These are the areas where these wealthy Indians are constructing their houses. So the Chitpur area, although there has been attempts of creating regulated growth, but still the growth is sporadic. Excuse me. And then comes the part of those few places which have seen post-independence expansion. Immediately after independence, around in 60s, 70s, there were certain peripheral area, peri-urban areas which were included in the main KMC or Kolkata Corporation area. One of them being this area called Lake Gardens. So these areas shows that there are parts which are planned on the right side as well as on the left side of the image. And then there are huge growth of slums and squatters which are taking place. So in the satellite image, you can clearly see that this whole area is a slum and squatter, which was unplanned part. So it's a peculiar blending of planned and unplanned cities which were going up hand in hand. And in the last example in this slide, I would like to highlight the how even after that, when absolutely planned cities were being laid out, how the city planning was happening in a part of the Salt Lake City, which were initiated long back in 60s, but ultimately came up. The whole construction ultimately or started. The urbanization ultimately finalized in 1980s. So these are the four different unique urban fabric which we can observe in Kolkata. More or less a combination or pure form of these fabrics can be seen in the city itself. And when we consider all of these, when you consider all of these, we find that the land use plan, which is there, shows that a total of the built up area, a residential area occupies 57% of it, which contributes to the majority of the urban heating of that particular city, and hence the importance of the intervention with the residential areas. Now, how does the building look like for these four textures or these urban fabrics? For example, we have seen the Governor House in the European quarter, and this is how the Governor House looks like. It doesn't have any or much intervention matching with the local climate of the city. This house was inspired by the Kettlestone Hall in England. And what the architect has done is that they have simply copy pasted the plan from that British setting into Kolkata. Whereas the climate and everything is different, absolutely different. They didn't consider it much. They simply copy pasted the whole design. And then later interventions like these yawnings, khajat, and all these things were added up, which were not there in the original building, has been added up with this copy. On the other hand, when we look into the Indo-Occidental indigenous buildings, what we find here is that, and if I just go back to the previous one, you will find that there are no courtyards. The whole building is a very much monolithic, a pure monolithic building, one mass extending its different parts, but it's a one mass. Whereas if we look into the Indian building typology, one example that I've included here is the Marble Palace, or it's the family of Maldiks. What we see here is that they are still copying the architectural elements from the British architecture. Many of the old rich people, businessmen or landlords, they kept copying the British or the European architectural prototypes in their houses. At the same point of time, if we look at the plan of the building, we will find a pure Indian layout coming up, as we have seen in the Havelis, as we have seen in the traditional house typologies in Bengal or in other parts of India. Courtyard centric planning coming up. So we have got courtyards in the plan, outer courtyard for out public, inner courtyard for the women folk and the male folk of the house. So hierarchy of courtyards coming up, everything of these corresponds to the Indian requirement and the Indian climate, the Indian socio-economic requirements and the Indian climate. These two are kept at paramount in these particular layout. Another example, one of the oldest houses in Kolkata, in urban Kolkata, belongs to the family of Devs. There is a place called Shobha Bajar where these Devs settled, and these are examples of that. If you look at where the highlighter revolves around, this is the outer house or the outhouse of the Devs, and this is the inner palace of the Devs for the family and all. So this was the original extent of these names. And then there is, at the same point of time, while they are making their own house corresponding to the Indian layout, at the same point of time, their successors are constructing monolithic structures, absolutely Europeanly designed monolithic structure, for necessities such as darbars or such other, I would say, drawing room requirements, where even Europeans were invited into those particular buildings. So the design corresponds to the absolute European typology. So now, while we have looked into the two distinct typology, our research did not consider the European prototypes, because the European prototypes, as we have found, did not necessarily correspond or care of the Indian climate. Hence, our entire research took care of the old indigenous houses which belong to Indian owners and were designed and constructed by Indian owners themselves mostly, or Indian engineers or architects mostly. So to do that, to actually identify these areas, the whole of these inner city, again on the western side is the river Hooghly. On the eastern side, this was, if you remember, the Maratha ditch, which later got converted into the circular road. So what we have done is that we have taken up this older part of the city as the northern Kolkata, as it is still being called the North Calcutta of Kolkata. The central part of the European part has been delineated again in this area, which is the European quarter. So in our study, we have not considered anything from this European quarter as such. And then comes this southern part of Kolkata, which mostly developed somewhere around late 19th century and early 20th century. So there is a time gap of almost 100 years, 150 years average, on an average, between the North Kolkata homes and the South Kolkata homes. So our most of the sample areas were from the North Kolkata region. If we look into the samples, in the whole research process, there were 20 samples that were considered, 10 of the from the old lots, 10 from the new lots. And if we look into the map to identify, the green dots and numbers shows the location of the old houses and the red ones for the new houses. These two tables show the dates for each of these houses. The old houses, the oldest of the old house, it belongs to 1782, as I have told you. And the last one that has been considered is from 1942. So all of them are pre-independence houses. Whereas the new residences, which have been considered, the oldest of them corresponds to 1984, and the latest was constructed in 2016. So an average of old buildings, the age was 148 years, average new building age was 21 years. So there is a comprehensive difference between these two sets of buildings. Coming to the study of the old residential building, these are some of the sample buildings. This building is the oldest one, constructed in 1782, having courtyards, multiple courtyards. If we look into the plan, we will find that there is one small courtyard right at the entrance, then one large courtyard having the Durga Dalan where the Durga Puja would take place. So this is the place where the Durga idol will be kept. And then there are steps in front of that, a huge courtyard. There are balconies around the particular area from where the women folk of the house can experience Durga Puja. When the outsiders are coming into it, obviously, because the whole puja will actually be conducted with the assistance or with the participation of the women themselves. So, but when there are, say, outside guests coming up, for example, in these old houses, many a times Europeans of very high rank, they used to be invited. So when those Europeans will come in to pay their respect, the women folk will actually go up into this particular balcony, experiencing the whole activity going on. And then there is an inner courtyard again. So it's a three-tier system of courtyard this particular house has. It's more of a linear layout of a house. Similarly, if we go to the next sample, which faces the previous house, although it has been constructed almost, I'd say, 40 years, 48 years after the previous one. This also shows a hierarchy of courtyards. So this is the outer courtyard that the photograph shows. The arcade, the green arcade that we can see at the end of the frame is basically the Durga Dalan where the Durga Puja would take place, and then the courtyard in front of it. Surrounded, this whole thing, the courtyard will be surrounded by colonnaded verandas. The right hand side photograph shows one of those frames, one showing one of those verandas. This is how the whole thing will look like, and so on and so forth. There we have also taken up as case study small buildings which doesn't have courtyards, but who have actually tried to create courtyard uh, from within the house itself by detaching built units from other built units. For example, in this sample, the house is so small that it was not possible for all the floors to have the courtyard. But the topmost floor in three-story house, they have created some sort of a courtyard experience by detaching the kitchen and the toilet blocks from the living quarters and by introducing small courtyard type of open areas. Whereas there is a rear courtyard which comes up from the ground to the topmost floor. This is the courtyard where my highlighter is there. So it's there. Some other examples where we have a courtyard in a very sliced manner. The reason being, this is a very long house, and then, as I told you, there have been several owners of the house from the original owner, and when the original owner is no longer there, the house has been partitioned into small segments, and hence we have got slices like this coming up. So actually, this is a slice of the entire house. The whole house has been divided into 5 such small slices. So if you join up all those 5 slices, you get a huge courtyard, uh, which is in scale similar to our previous case study. Other examples, large scale buildings like this, having again multiple level of courtyards and colonnades around it. This is another example of it. Now, coming into the unique design components of old residential building. When we study this old residential building, there are certain unique components which come which are typical of these indigenous residential buildings of Kolkata. So we've tried to enlist them. There are 7 such unique elements. The first one being an ornamental entrance to the premise, such as a lion door, Singh Darwaza as we sometimes call it. So this is that. This is from the Dev family, from Shobha Bajar. The second component will be portico or porch. Now we have to actually understand the beginning of these interventions of these indigenous houses, when there were the practice of taking the car or taking the vehicle, cart in this case, horse cart, not inside the house. So then there used to be a entrance like this, but then they started copying the Europeans and started bringing the cart or uh, this horse-drawn carriage into the front of the main entrance under a portico. So portico started coming up like this. Porticos are porch. The third part, after we enter inside the building, into the first courtyard, the public courtyard. So these are the colonnades or arcades around the courtyards, along passage. Fourth is when we enter inside the building and get inside the top portion, we have those ornamental staircases. So these are examples from 2 such case studies. The left one is from the Ghosh family, right one is the Basubati. Then we have decorative sculptures, stucco molding, wall motif, etc. These are the elements that we can see in these houses. Then stained and tinted glass windows, another typical feature of these old houses. And the last one being wrought iron, decorative and utilitarian elements. Both decorative, for example, benches or such filigrees, frames, everything coming up in this particular part. Going into building material and construction, the build materials that were used typically in these indigenous houses includes, not exhaustive, but majority of them includes bricks of different shapes and sizes, not only the standard 250, 125, 75 brick that we see right now, but there are various tablet bricks, small bricks which were employed. Lime stucco, the lime plaster that that they have used. In certain cases, we have found lime plaster of a thickness of even 2 to 3 inches being used in these houses, which considerably helps the thermal cooling of the interior of the house. Cast iron members, mostly decorative members, bamboo and khastas to actually create screens from the direct sunlight to the balconies. Terracotta in terms of tiles, terracotta in terms of arch springing tiles, terracotta in terms of decorative tiles, stained glass, and Dutch wall tiles, which were mostly used for shadow and skirting inside the building itself. Coming into the new residential samples, they are more compact. They lack those courtyards. They lack those colonnaded balconies or verandas. They are more a compact unit. In many cases, this actually results into a lack of cross ventilation, except for the corner rooms, which obviously can have the luxury of corner windows, cross ventilation, ensuring cross ventilation. But most of the sandwiched inner rooms lack that cross ventilation. And even smaller units doesn't even uh, afford to have those climatological interventions. Some examples I'm quickly browsing through. These are elements of apartments, as colloquially we call them as flats. Some of the other examples. Now, after we have surveyed and studied those buildings, we have got these we have installed temperature and humidity data loggers in these houses, and which have recorded uh, the data on temperature and relative humidity both at an interval of 15 minutes. So from each house, you have got around 300 continuous samples, and then they have been analyzed. And new index have come up. These particular tables, the representative tables, show you one particular index called heat index. We'll come to that in a later slide. So please remember, I'll refer to that. This heat index is a composite index that has been used in this particular research. Coming to the research objective one, the objective one was to find out whether old buildings were more comfortable than the new buildings. So for that, we needed to compare them. So in this particular comparison, we, as I told you, we have considered thermal comfort indices, which doesn't take into consideration this user feedback in the thermal comfort. They simply take up non-human thermal comfort parameters, converting them into those indicators. One is heat index, as we have already seen in these tables, those heat index columns, and adaptive comfort temperature, or ACT, under which again we have got two further sub-indexes called PCH, percentage comfort hours, and CF, comfort fraction. So to get to these indexes, HI, ACT, PCH, and CF, we have required these three raw data which we have collected in those buildings itself: ambient temperature, relative humidity, and air velocity. When we feed those data, the heat index of inside each building could be calculated using this particular formula, and with a few minor adjustments, as this part of the equation shows. Because in most cases in Kolkata, whether it's an old building or a new building, the relative humidity always, on most of the time, crosses 85%. It's very common phenomenon. So in cases where it crosses 85%, we had to do that adjustment. And coming to the second part, ACT, premise of ACT, as all of you know, goes back to the works of Humphrey, which he conducted in 1978. And since then, various ACT models have come up as proposed by experts in this field. So we tried to list them, the various ACT models which have been worked upon. Say the initial one proposed by Humphreys, then Oliclim's proposed one in 81, Griffith, Nicolan Roth, and Zokole. These are all different adaptive comfort temperature model, which gives the neutral temperature based on the average outdoor temperature. Now, most of these ACT models were developed outside India. So as a case study on which they were based, or as a case data on which they were based, most of them were, almost all of them were non-Indian from other countries. So in India, to compensate to this, initially, researchers like Sangyevita Manu and team, they developed one Indian model for adaptive thermal comfort called IMAC in 2014, which gives it the equation is this: neutral temperature, or TN, is equal to this. However, for this IMAC model, the data was mostly taken from office-oriented buildings and also for uh, this non-ventilated shells, that means mechanically ventilated interiors, air-conditioned, air-cooled interiors. So that is why, again, this ACT model could not be used for our purpose of our research. We further explored, and then finally we came up with this particular ACT proposal proposed by two researchers, Nayak and Prajapati, in a handbook on energy conscious building, a work which they have done on behalf of IIT Mumbai for the Solar Energy Center, Ministry of Non-Conventional Energy Resource, in which they have given this particular ACT. This particular model does not consider any manual feedback on adaptive or on thermal comfort. It's a complete non-manual one. Hence, this model was the most suitable one. And when we uh, compared them with one base value of TO as 25 degrees centigrade, what we have found is that the different ACT models uh, predicts the values with different levels, in which the Nayak and Prajapati model is one of the highest, actually the second highest, but as because we are not considering models till Zocole, which are all outside, have been developed outside India. So out of the two Indian models, this is quite a positive steepness of ACT, giving us a higher side estimate of the adaptive comfort temperature. Uh, if we can satisfy that value, we can satisfy even lesser values as well. Coming to PCH, the percentage PCH, the percentage comfort hour is given as the percentage of hour in within a building, which falls within the ACT plus 2.2 degree and ACT minus 2.2 degree, within that range. And the hours for which the whole building is coming within that hour divided by the total hour of total study hour. So that is the PCH, and from PCH we get CF as or comfort fraction as 1 minus this discomfort degree hours, which is again given as 100 minus PCH, obviously. So whichever is within the comfort, the rest of it is in the discomfort area. So discomfort degree divided by 105.6. This equation gives the comfort fraction. So these are the three types of indicators that we have got. Then we started comparing the two sets of data on the basis of these indicators. Initially for heat index, which is a composite value, takes care of temperature, relative humidity, air velocity, all the three basic parameters. We have got this HI value, and then it's a simple statement of what were the confidence level and what is how the testing has been done. And hence, ultimately, we have found that the average heat index of old buildings are lesser than the average heat index of the new building. That means, in simpler terms, the old buildings were found to be actually cooler than the new buildings over a sample of around 300 data collected in all these 20 buildings, 300 sets of data in each building. Now, the same exercise was done on the basis of ACT and comfort factor fraction, PCH and comfort fraction for old buildings, PCH and comfort fraction on new building, and then again the hypothesis testing was done. And in each case, we have found that the hypothesis was proven true. That means the percentage comfort hour for old buildings is more than percentage comfort hour in new building. That means the old buildings is providing me with more time of comfort than the new building. Similarly, comfort fraction is more in old building than comfort fraction that we find in new building. So that's how the whole thing was done. And in the conclusion for this first objective, what we have found is that into a total 20 buildings were studied as part of this dissertation with representation of old and new building. The thermal data collected for continuous 48 hours in each building with temperature data logger with an interval of 15 minutes were collected. These data were then processed to convert them into the two thermal indices. And the findings of the hypothesis testing concludes the first objective that the old residential buildings actually have better thermal performance than the new residential buildings of Kolkata. And then after we have ascertained that, we got into the second part was that what were the building components which were important for this. And for that, we identified five basic building component which contributes to thermal comfort of a building. First of all, the orientation of a building. Second is building material and their thermal conductance. Third is surface area to volume ratio, that is S by V ratio. Fourth is shading of the building scheme, which can happen individually, independently with the help of dhaja, portico, etc., or can be mutual shadow that has been, or the shadow of adjacent buildings. The mutual shadowing again can be of two types. Building itself is casting shadow on another part of the building, which happens mostly for the courtyards, courtyard centric buildings, and then shadow of adjacent building or any large tree. Flora is the large tree adjacent to the building, falling on the shadow falling on the building surface itself. And then the last component is ventilation of the interior space. So these were the five basic parameters. We have collected data for these five basic parameters. The first one is building orientation. And then again from handbook, we have got the orientation of building and the scaling factor of each of these orientations. So we have got those scale factors. These are the different buildings and the orientation factor. Similarly, thermal conductance, U value were calculated for each of the building. We have measured the thickness of the wall, thickness of slab, material, and everything, and we calculated the U value for both old buildings, the walls of the old buildings, roof and slab of old buildings, similarly walls of new buildings and roof slab of new buildings has been calculated. Similarly, data on surface area is to volume ratio were also computed for each of these buildings. Shading of the building scheme and the ultimate total radiation on window were calculated for old and new. Then opening versus wall ratio was also calculated for old and new buildings. And then ultimately, the air velocity ventilation of the buildings were computed for both type of buildings. Again, we went into the heat index chart and tabulated the data in this manner. So for old and new buildings, we have the DVT values, we have the heat index value, and the values of different parameters. So these are the indicators, and on the right hand side are the parameters: orientation, air velocity, shading, surface volume ratio, thermal conductivity, and opening versus wall area ratio. So, and with this particular thing, we have done computation and interpretation of correlation coefficients between the indices and the building parameters using SPSS. So first we did it for the old building, and then we found the different correlation. We have conducted the correlation with BBT as well as the heat index. That means the basic raw data as well as the composite index. And for the composite index, we have found that surface area versus volume ratio has moderate as well as opening versus wall area also has a moderate influence on the heat index of the building. The more is the surface area versus volume for these residences, the more we have the thermal index. The less opening there are, we find the that is negatively correlated. Similarly, for new buildings, it was also done. But in this case, for new building, we haven't found any predominant layer, whereas thermal conductivity of the slab, the more the thermal conductivity, the lesser is the comfort inside. So that's what we have found, obviously. So objective 2 also has been thus fulfilled. The coefficients show higher degree of influence of surface area versus volume ratio and moderate influence of thermal conductivity of wall in old buildings. These are the predominant parameters which affected these buildings. So on the other hand, the coefficients of new buildings do not show any high degree of influence on the thermal comfort indices. 4 out of 7 parameters, however, have moderate influence over the comfort indices in the new building. So with that, let us conclude today's presentation. I hope that this case study of the research would help you in your learning. So with that, let me conclude my presentation and over to Professor Shubham Meena.
Yeah, thank you, sir. Now the platform is open for the participants. If they have any query, they want to any discussion with the experts, please ask the expert directly. Participants, if you have any question, you also can write in the chat box.
Sir, have you calculated this U values of the walls or roofs?
Yes, for the sample buildings, the U values for the walls and the roofs were given.
But how you calculated with the constructed ones, sir? Like any sensors or
No, actually, the more common or accepted method is to put up sensors. But in this case, we couldn't convince most of the residents that these interventions are non-invasive, because in most cases that they have seen or encountered such intervention, they were invasive intervention. Uh, Parts of the building clusters have been affected because of those things. So although we could try to convince them that the instruments that we would be using were non-invasive, they were not so much convinced. So in this case, what we have completely relied upon is, fortunately for most of the old buildings, when we conducted our research, we have found there are certain areas or certain parts of the buildings which are broken off, which are broken down, and that expose the cross section of the construction. So from that, we actually measured the cross section of the this construction, found out how much of plaster, how much of brick, and other materials which have been used over there. In most cases, we have found brick, lime plaster were the common material for the old building. In few cases, there were dados as well, these tile dados as well. So in those cases, it was very easy for us to understand the building material that has been used for the rooms as well. The same material we have assumed for the rooms. For new buildings, in most cases, fortunately, the drawings itself, document itself has the listing of material for the newly constructed houses. So from there, we could clearly find out the cross section and the material used. So that way, we had to calculate. But the most unambiguous method would be using sensors.
Have you done any models for simulation, sir?
No, we haven't actually worked on that yet, but we are actually on the process of cross-checking, or I would say using the data on a simulation or something like that to develop a numerical model.
Okay, thank you, sir.
Thank you.
Any other part? Okay, thank you. So with this,
Thank you.
so okay, thank you all. And with this, we are going to conclude the session. So we are sincerely grateful to our esteemed speakers from an enlightening presentation that offered not only the theoretical foundation but also a detailed comparative analysis on the thermal comfort across the 20 residential samples he taking. That's both from the new urban houses and old houses from Kolkata city, and the discussion brought to light and the significant differences in the thermal comfort, passive design strategies, and occupant comforts, that highlighting how that they can inform and enhance the modern architectural practices, particularly in the pursuit of energy efficient and climate responses in urban living. So we hope this session has sparked a meaningful reflection and inspired new lines that brought in your teaching, research, and design work. So thank you once again for your active participation, and we look forward to continue involvement in the upcoming session of the FDP. So thank you, sir.
Thank you. Thank you.
With this, we now go to close the session, and we will meet the next session again at 12 p.m. So thank you, everyone.